Consider points 3, 7, -2 for P, and Q being 1, 1, -3. Determine the angle between vectors OP and OQ. Express the answer in degrees, rounded to 2 decimal places. So there's a few things that are interesting here that you might not be aware of. So the first thing is the points are kind of obvious there. No big deal there. But when it comes down to finding an angle, that's the first thing I want to point out, we're going to need a formula. Now, this is vectors we're talking about, so the angle between vectors. So that means we're going to use that other formula for dot product here, and that's this one. Okay, another thing that's interesting about this problem that you may have not picked up on is the vector OP, because all they did was give us a point here, 2 points actually, and they want us to get 2 vectors from those 2 points. So what O represents, and this is something you may have not known, O represents the origin. So when I see this O here, I should think of origin. And the origin here, since these vectors, or these points, are 3-dimensional, so the origin is going to be 0, 0, 0. But since our points are starting, or our vectors are starting at the origin, that makes the vectors really easy to create. So vector that uses point OP here is going to be 3, 7, -2. And we know this because this is where it stops at. If it starts at the origin and stops at a point, that endpoint is going to be the components of my vector. Now I switched it around. Now for the other point, or the other vector, and that's OQ, that's going to equal 1, 1, -3, for the same reason OP was what it was for P, point P. So now what we're going to do with these is we need to find the angle between these. So I'm just going to set this up for what I know. So I need to know a few things here. So I need to know the dot product of U and V. I need to know the magnitude of U and the magnitude of V. And knowing those components, I will be able to solve for theta here. And that's what we need to do here. So we're going to do the dot product first of vector OP and OQ. So OP dotted OQ is just 3, oops, let me fix that 3. And dotted with negative or positive 1, 1, -3. And then I just multiply. So that's going to be 3 times 1. And actually, I'm not going to write this out anymore. I'm just going to go 3 times 1, which is 3. Oops. And remember, it's the sum of these. I almost tricked myself there. 7 times 1, which is 7, plus -2 times -3, which is positive 6. So here I get 16. So one thing I know right away, and if I was looking for this, I could say that these vectors are not orthogonal because this here is not 0. But we don't need that here. So anyways, that's just a bit of information. So now we're going to find the magnitude of U. And we also need the magnitude of V. So let's find that one now. So the magnitude of U is just the square root of 3 squared plus 7 squared plus -2 squared. That's how we find the magnitude of u. And I shouldn't say u here. I should actually write the vector in there. Let me be more specific with those. That's OP. Vector OP. Okay, so then that equals the square root of 9 plus 49 plus 4. So then our answer becomes 5862. So square root of 62. And I always look to simplify these. But the square root of 62, if I think of like dividing it by 2, that's going to be 2 and 31. So neither one of those are going to result in factors that are perfect squares. So I keep it as square root of 62. Now I'm going to find the other one, OQ, the magnitude of OQ. So 1 squared plus 1 squared plus negative 3 squared. Now notice here, I did actually put a parenthesis around the negative 3. And that's the only time I really have to here. Because if I tried to plug it in my calculator, it wouldn't read the negative right if there wasn't parentheses. It would actually just do the 3 squared first and then negate it. So that would mess things up. So make sure you use parentheses for those if you're just plugging this in. So here's going to be 9 and 1 plus 1. So we're going to get a square root of 11. Okay, so now we have all the information we need for this problem to plug it all in to this formula here so that we can find theta. So u dot v is 16. I'm going back here. Okay, so I'm just going to put a 16 there, and that equals my magnitude of u. And I shouldn't say magnitude of u here. I should write it this way. And I'm going to write the formula out first, and so that you can see where everything's going. So that gives us this formula here. So my first vector here was my u up here. I have my v here, my OP, my v, and my cosine theta here. So you kind of see how it's all set up. So now all we're going to do is plug in all the necessary information that we have already. So my dot product here is 16. So I'm going to put 16 here, and that equals my OP is over here. So that's square root of 62. Oops. And that's times, and then my magnitude of my OQ is going to be the square root of 11, and then cosine theta. So now I'm just going to divide by this. Square root of 11. And then now I have the cosine of theta equaling 16 over square root of 62 times square root of 11. Now I'm not going to worry about multiplying those together even though they're under the same powers. I'm just going to take the cosine inverse of both sides now. So then I get theta equals cosine inverse of that 16 over square root of 62, square root of 11. And that's going to be my theta here. And it's going to be an approximation, of course, because that's not going to get me anything. That's going to be a nice number that we're accustomed to for trig functions. And this turns out to be 0.091, two ones, 36, blah, blah, blah. So that's our answer for this one. And again, this would be radians, so make sure you're aware of your units. So there's our answer. That's the angle between those two vectors.